This is about partial fraction decomposition. Just title this partial fractions. Homework, blah, 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 spring break, yes, and test after break. Okay. So we did this part. I'm gonna skip the scratch work. We had 2 over x plus 3 minus 3 over x minus 1 equal to dot, dot, dot. Negative x minus 11 over x squared, add 2x, subtract 3. So the goal in this chapter is to take something that looks like this, rewrite it like that, and then integrate this part. So if you have an integral of this, negative x minus 11 over x squared, we add 2x and subtract 3 dx. It's equal to the integral of both of these terms here. So equal to, let's just rewrite, let's read. Okay, so we're at the integral of 2 of x. We need a denominator, x squared. 2x. Integral 2 with a 1 over x plus 3. Okay, subtract 3 times the integral of 1 over x minus 1 dx. Okay, for this side, I let u equal x plus 3. You would take the derivative, get du dx equal to, it's going to be a 0 and 1. So du equals dx. Two integral 1 over u. Over here, you could use u, but just to kind of be more clear, I'm going to let w equal x minus 1. Okay, dw dx would equal 1, so dw equals dx. So 3 integral 1 over w dw. Okay, this would be 2 times ln of the absolute value of u minus 3 times ln absolute value of w. we add c. Did I add c? Yep. Let's put plus c in at the end. Well, I don't think now. We just need to actually write these guys in here, and we can still carry this down. Plus c. To ln absolute value of x plus 3. Subtract 3 ln of the absolute value of, let's see, x minus 1. All right, now we need to work on how to get from here to here. So there's steps to go through, and then some practice. To find the partial fraction decomposition. Of the function f of x equal to p of x over q of x. We could put a capital Q. It's cool. Okay, you start by factoring the denominator. Factor q of x. Hopefully into linear factors. Let's see. Let's phrase it so that it says factor q of x, then for each linear factor, ax plus b. Okay, so a and b are numbers, b is a variable. So we've got this kind of factor. You write a term of the form Okay, so the term will continue here. So it looks like a fraction, some unknown number a, capital A, over ax plus b. For each factor like this, write a term like that. And I want to put an extra little part here for each distinct factor. So every distinct. Ax plus b, you have that part. A over ax plus b. Okay, for repeated factors. So they aren't distinct, there's more than one. Okay, you have something like ax plus b to a power n. it's repeated, so n is greater than 1. It's not the power 1, it's like squared or cubed or more than just one of them. Okay, you write terms. Write n terms of the form. Let's see, it's a sub 1 over ax plus b. Add a2 over ax plus b squared. Okay, till you get to the last one, a sub n over ax plus b to power n. Okay, so the first example we'll have a lot of distinct factors, and I have an example with a repeated factor, and I think that's about all we're going to do today. So, first one. The denominator, which we called q of x, q of x factors into distinct linear factors. Okay, so we have, so it's the same problem that we did before, but showing you how to get from that step to the other. And then we can just jump to what the answer was. So we already worked through it. Let's go ahead and have that factored form of the denominator. It was x plus 3 over x minus 1. Okay, how to get from here to those other two integrals we had. You have one linear factor, so you need a term like this. For that linear factor, we make another term, pick another letter over that as the denominator. Okay, and what we want is for this plus this to equal that. So that's this, add to this to be equal to all of this in here. Oops. Okay, so we, right now I'm just going to rewrite this actually. So a over x plus 3. Added to b over x minus 1 equal to negative x minus 1. trying to solve for those values, a and b. So let's multiply both sides by that LCD, x plus 3 times x minus 1. So multiply both sides by x plus 3 times x minus 1 to get a times x minus 1 plus b times x plus 3 equal to negative x minus 11. All right, this is true for all values of x. So you can pick any x value. Choose something that helps like solve for a and b. Like right here, if I put x equal to 1, this will be 0, and then I can figure out what b will equal. All right, so I said x equal to 1 gives me a times 0, a times 1 minus 1, plus b. All right, 1 plus 3, and equal to negative 1 minus 11. 0. 4 times b, and is equal to negative 12. Okay, divide both sides by 4. And b is equal to negative 3. I can go ahead and, I think I'm going to put that in here. Let's go ahead and rewrite this all up at the top. So, still need to figure out what a equals. But I got b and equal to negative x minus 7. Okay, so again, any x will work. So what kind of x would help? I had, let's see, I picked. Oh, actually, I solved this another way. It's cool though, it's fine. We'll pick some value for x. And, there's all that's left to solve for is a, so. Just as a side note though, the way that I did this as my scratch work was as like a system of linear equations, and it just used like elimination to solve for my variables. But also you can pick x values that help solve for those variables. All right, let's try x equal to, let's pick 2. I have a times 2 minus 1 minus 3 with a 2 plus 3 equal to negative 2 minus 11. 2 minus 1 is 1. A minus 5 was multiplied by negative 3. And a negative 13 on that side. Okay, A is equal to 2. So that's how I got from that first integral to the second integral. We can write, let's see. The first part was negative x. Subtract 11 over x minus 1. X plus 3 dx. We know what a is equal to, and we know what b was equal to, so we're going back to those two terms that we had. So, and then we're integrating both of them. Let's go with the whole thing at first. So let's go with a was equal to 2 over x plus 3. We have b equal to negative 3. Make sure it's right. Awesome. And we already know what the answer is. So that was just the point, is to show you how to get to a problem that's easy to integrate, but still the same problem. All right. Next one, we have this kind of integral. Actually, we'll call it case 2. Where q of x has a repeated factor. We want to integrate. Let's see, the denominator fractions into this repeated factor. All right. The integral of 11x squared. Add 2x, add 3. And it's over. 4x times x plus 1 squared. I put a side note that you can, or left, tongue-tied. Let's just write it down. Okay, the degree of the numerator, which I'm going to call p of x, is 2. Okay, the degree of the denominator, which we're calling q of x, is, let's see, multiply everything out and it would be degree 3. So when the degree of the numerator is less than the degree of the denominator, we will not try long division. But if it's the other way around, try long division. We'll see if we get to something like that later. I put down no long division. So what we'll do is write a term for each of your factors. That has those forms we talked about before. term for this part, 4x, and there's two terms for this repeated factor. So I have got something like this. A over 4x. Add. Call it b over x plus 1. And add c over x plus 1 squared. And it's equal to all of this right here. So that's what we want. We want this to equal something that we can integrate. And if you had room on your page, I would put them side by side, but we're going to have to kind of stack it on the whiteboard. All right, so this would all be scratch work right now. Scratch. Cool. So we're trying to solve for a and b and c, and let's get rid of all of these fractions. So multiply both sides by the LCD, 4x times x plus 1 squared, to get a times x plus 1 squared. B times 4x times x plus 1. Okay, plus c times 4x. And then everything is equal to this equals 11x squared plus 2x plus 3. Okay. Again, this equation is true for all values of x. So choose any x value. To get a, b, or c. All right, I picked some good ones. So the first one I got was -1. That one gave me C right away. But there's nothing special about the numbers I pick. You can pick whatever x values you want. Just work through all the scratch work. Try. All right, so this would be a times -1 plus 1 squared, which we're gonna jump to putting in 0. B times -4 times 0. Okay, add C times -4. Okay, equal to good, cool. -4 squared. 2 times -4 and add. Oh wait, that's not a -4, it's a -1. Ah, there we go. That's a lot. Put in -1, and then we put in -1, and then we put in 4 times -1. And then -1 squared, and this is like gotta be the right number, and that's better. Okay. Zero plus -4c is equal to negative, actually that's going to be 1 times 11, so it's 11 minus 2, add 3. -4c equal to 12. C will equal -3. Oops. Okay, we will get some other value of x to solve for one of our variables. Let's try x equal to, see, I picked 0. Back up here, x is 0. So we're putting a 0 in for x, we're putting a -3 in for c, and then we'll see if we get a or b out of that. A times x plus 1 squared. Oh, we're putting in 0. Cool. Next. Plus b times 0. Okay, it's going to be plus b times 0. You don't really have to worry about the rest. And then minus, okay, 12 times 0 equal to, let me just make sure I'm not skipping too much. A times 0 plus 1 squared, sweet. B times 4 times 0, it's going to be 0. And minus 12, 0, equal to 11 times 0 plus 2 times 0 plus 3. And that's going to be a plus 0 equal to 3. Make sure that's good. Cool. Next, let's get some value of x. And at this point, any x will work, but I picked a nice number, picked 1. Okay, putting in 1 for x, we know a and we know c, so we'll figure out what b is. Ooh, it's going to be 3 times 1 plus 1. B times 4 times 2. Add C, which we already know is -3. And then we found C. c is -3, and it was multiplied by 4, and we're putting in 1. So this is going to be -12. Okay, the other side, plug in 1 to get 12 plus, or sorry, 11 plus 2 plus 3. Okay. 12 plus C, 8b, and -12 is equal to, go 11, 12, 13, 14, 15, 16. Okay. 8b equal to 16. And b is equal to 2. Okay, so we have A and B and C, so those 3 terms, we'll plug in all those numerators to them. So let's also write the part where we have the integral included. So we'll go back to the original problem, the integral of 11x squared plus 2x plus 3. Over 4x times x plus 1 squared. All right, integral of C. A was 3, so we've got 3 over 4x. Plus 2 over x plus 1. And then C was -3, so -3 over x plus 1 squared dx. And then we'll do each of these integrals, like term by term. Okay. All right, so I'm just going to put a note that for this piece here and this piece here, you would do a U sub. Actually, let's just do it together. I'm trying to jump around. Let's do this. We're going to need space to work through. So we're going to rewrite everything, and then we will do each of the integrals together. I think we have time. Oof, nope. Okay. We're almost out of time, actually. So let's write the answer down, and then maybe next time we'll come back and just do a bit of scratch work together. But we'll wrap it up and then come back later to explain what happened. So you will get 3/4 ln absolute value of x. Right there. Add 2 times ln absolute value of x plus 1. And then there's another u sub here, which would give you plus 3 over x plus 1. And add c. Okay, so it's just because we're out of time that we jumped to the answer, but I'll work through these steps next time before we move on. All right, that's the end for today. Thank you, everyone. And let's go ahead